Hey, welcome back. We're gonna go through quadratic function basics and we're gonna do a revision here. Alright, so pause the video, try to have snapshots of all the following examples and problems. That's sort of GCSE like problems, and here we go, we start. First one. Alright, for each of the functions below, find the value of y when x is negative 2. So, okay, just remember what about function, what it tells you. Just give me the argument for x and I'll give you the output for y, right? So that's input and I'll give you output for y. So we know x, so basically we know input, and we're gonna just calculate according to specific rule set up here by each function. We're gonna calculate the outputs. Okay, so first one, 2x squared plus 9x. We're just simply doing the following. We plug where x stays negative 2 and simplify that. Alright, so negative 9 times negative 2 as well. So we'll get this. Now, let's square it up. It's 4. 4 times 2 is 8. And 9 times negative 2 will get negative 18. Finally, we'll be left with negative 10. Alright, so let's go next. 4x squared plus 7x plus 1. From where we do the same. So we simply calculate y from negative 2. We have an input negative 2 and we plug in. Alright, so 4 times negative 2 squared, and then minus 7 times 2, so I put minus just in before, and then plus 1. Alright, we'll get 4 times 4 is 16, then negative 14, and plus 1. Finally, we'll get 2 plus 1, which is 3. Okay, so that's the final result for any given input. The same actually for both functions. We'll get different output because of different rules set up by each function. Alright, so let's move next. State whether the following quadratic function pass through the points. Alright, so we have points here that are points 0.0 and 4 and negative 1 over 2 and minus 4. So actually points set up by a set of coordinates x and y. And let's consider the first one. So what we understand under the terms or under expression that quadratic function pass through the points. So graphically it means that if you have quadratic function like sort of parabola, it passes through the point. So, okay, so how to work it out? How to work it out that this is exactly pass through the point? We simply need to know the following. We just need to plug the point, right? The coordinates of the point instead of y and x, and see whether we'll get the right equality. So let's do that. Sorry for interruption. Okay, so let's do that. We just simply have 6x squared minus 10 equals to fx. But in other words, fx is the same as y, right? So we're doing the following. This is x coordinate of the point. This is y coordinate of the point. We take x and plug here whenever x stays. We're taking y and plug instead of y in the function. So that's your function, that's your y value. Okay, so 4 on the left hand side will be equal to, what's going to be on the right, simply 6 times x is 0, so 0 squared, and minus 10. Finally, we'll get the following. 6 times 0 is just 6, and we'll get 4 equals to negative 10. Does this function pass through this point 0.4, like 0 and 4? No, because the equality is incorrect. So 4 is never equal to negative 10. That's why it doesn't pass through. So the answer here doesn't pass through. All right, pass through. So next, negative 1 over 2, that's again x coordinate, negative 4 is y. here we stated that y equals to negative 4x squared plus 6x. What we're going to do, we're going to plug instead of y negative 4, so we have negative 4 equal, let's say what's on the right side, negative 4 times x squared, but x squared is 1 over 2 squared, so it becomes positive, and that means we have 1 over 2 squared. So plus 6x, so simply we'll get negative 6 times 1 over 2. So I'll already take into account this negative sign and just from negative 1 over 2 and put it in before 6. Alright, so let's simplify. We'll get negative 4 on the left hand side, and let's see, negative 4 times 1 over 4 we'll get simply negative 1, and negative 6 times 1 over 2, we'll just go and cancel that. We'll have 3 left on top, so we'll get minus 1 and minus 3. And indeed, we'll have the right equality now, so it's correct, so it passed through. Alright, so it passed through the point. Okay, so it's done. So let's move next. Exercise 3. For each of the following quadratic function, find the values of x for a given value of y. Okay, so in this case, we just need to find a reciprocal, like we need to solve a reciprocal problem, so inverse problem. For given output, so for a given value of y, so we're given output, simply y, we need to calculate input. So in other words, it's x. So find x. Okay, so we have y equals to x squared plus 5x plus 8 when y is 2. We simply take y equals 2 and plug instead of y, and we'll get the following equation. So that's, let's say, 3a. So we'll be solving 3a, and we'll get the following: 2 equals x squared plus 5x plus 8. Okay, so that sort of equation becomes quadratic one, and we simply just need to take 2, transfer it to the right side, and have the following equation in the end: 5x, so 8 minus 2 becomes positive 6, and we'll get pretty nice lucky numbers. So I'll do it by factorizing. So obviously it's x plus 2 and x plus 3. So for those who don't understand why is it so, just give the I'll give the reference to factorizing. So we did it before when we used to solve quadratic equations. So check the quadratic equation topic, quadratic equations. All right, and you'll find how to solve that. Okay, so next one, from where we will get x equals negative 2 and x equals negative 3. So keep in mind that quadratic equation must have 0 or 2 or 1 or 2 solutions. So in this case, but the maximum number of solutions, that's 2 according to the maximum power of the equation of the term x. So the leading term x squared, so it's quadratic, so 2 solutions at most. All right, so let's move next. 3b, it's here. Y equals 3x squared. We're given that y is negative 3, so we plug negative 3 here on the left hand side equals 3x squared. All right, so what sort of equation? Of course, we can simplify that, but it doesn't make any sense because we already know that on the right side here, right now, or on the left hand side here, we have a negative number. So just remember quadratic equation in the simplest form. So make sure you remember that simplest form for quadratic equation, like sort of x squared equals k. And if k is negative, no solutions, right? So no solutions here. So it means that for y equals negative 3, this graph is just unable to deliver any x corresponding to y equals -3. Okay, so I'll give you extra bonus. So make sure you've done all correctly. This is the chance to check yourself, guys. So that's the answer for everything, for all 3 problems. But I'll give you a bonus for the last one. All right, so let's see. We have y equals 3x squared. We have y equals 3x squared. Let's do it graphically. So we haven't done graphs yet, but however we can like try to plot it. So maybe students who remember that and just revise the quadratic equations and functions, they are able to do that. So we just simply plot the graph y equals 3x squared, and let's see how it works. It goes through the origin, and because the leading coefficient a is more than 0, in this case it's 3, so we plot in the graph y equals 3x squared. Okay, so it looks like that. So completely above x-axis except for it goes through the origin. However, y -3 can be possible for this parabola to have y negative. No. So actually the range of this function goes completely above, right? You see that all y's for that function. So no matter which point you take, so for this point, for example, y value is here, for that is here. So the minimum point at the vertex, and it's not going to be lower than 0 or less than 0. So y equals -3 is here. So there is no point on the graph. So that's why no single value for x can deliver y equals -3. So for x, there are no solutions for that. Okay, so that was a little bonus for you guys. It just like sort of starter before we start exploring quadratic functions. I mean, in terms of how to plot them, how to visualize, and this is what you need to think about for those who haven't started yet. All right, so guys, hope you enjoy, hope you like that. Just don't forget to subscribe and share that like useful ideas for everyone who's going to prepare for this MOOCs 2019 or maybe next year. I'm definitely sure that this video and all my series will be useful for like further generation of the students. So peace here.